Two balls of equal mass undergo a two-dimensional elastic collision. So we need to prove that the final velocities are perpendicular to each other. That means the directional motions of the two balls after collision are perpendicular to each other. Or in another word, the two angles, alpha beta, their sum should be 90 degrees. So for collision, then we can use momentum conservation. Because a two-dimensional collision, then both x component and y component are conserved. Second, because it is elastic collision, kinetic energy before and after collision should be equal. And then we try to prove alpha plus beta should be equal to 90 degrees. Because px is conserved, so we can write down the equation. V1 prime, no arrow, means they are the magnitude of the corresponding vectors. So this is how to calculate the x component multiplied by cosine and the angle plus using cosine ratio. And for y component to be at the beginning, ball 2 is at the right, ball 1 is moving to the right. So they are y component or momentum, both are zeros. So it's just 0 equal to, for ball 1, it has a positive component. So ball 2 has a negative y component. So this is equation 1, equation 2. Consider kinetic energy. Before and after, the value should be equal. So before collision, only ball 1 moves. And then after, both balls are moving. So this is equation 3. This equation can be simplified. You see common factor mm 102 102. So then we simplify it. So then first equation will become like v1 prime cos alpha plus v2 prime cos beta equal to v1. Let's call it equation 4. Second one can be written as v1 prime sin alpha minus v2 prime sin beta and equal to 0. Let's call it equation 5. Last one, cancel 1 2 and then m, so we got v1 prime square plus v2 prime square equal to v1 square. So this is equation 6. Okay, we got a v1 square. This is v1, and so we want to square equation 4 and equation 5. And after we add them, so this way left side will become v1 prime square cosine alpha square plus 2 times v1 prime v2 prime cos alpha cos beta plus v2 prime square cos beta square plus this square of this side. So it is v1 prime sin alpha square plus, it should be minus 2 times v1 prime v2 prime sin alpha sin beta plus v2 prime square sin beta square. This is the left side. Right side will be v1 square plus 0 square. It's just v1 square. And let's call it equation 7. So that v1 square should be equal to v1 prime square plus v2 prime square. So then, but left side of our equation can also be simplified. So we simplify the left side. You do the sum top down. You do the sum of these two terms, which will be just the v1 prime square. You do the sum, these two terms, they are just the v2 prime square. And then these two terms, they are common factors. So we factor out the common factor to v1 prime, v2 prime, and then you got a cos alpha, cos beta, minus sine alpha, sine beta. So this is the left side, simplified. And right side is v1 squared. But by equation 6, v1 squared is the sum of squares. So it's v1 prime squared plus v2 prime squared. And then we cancel the same terms on the two sides. So that means the bracket should be 0, because v1 prime, v2 prime are speed, they are not 0. Now we use the compound angle formula to simplify it. This one can be written as cos alpha plus beta, and it should be 0. So here we use the compound angle formula. If you are not familiar with it, then you Google it. That means alpha plus beta, because both are acute angles, the sum should be 90 degrees. That means the direction of motion, or say the velocity of the collision, should be perpendicular to each other.